My today presentation is about architecture commands. Yet another walls, doors, and windows that we saw several times during these 2 days, and it was mentioned several times that there is such a module in IntelliCAD that was added quite recently. Let's say just a few words about the ADT architecture library itself, with no respect to IntelliCAD. First of all, ADT architecture C++ libraries, which I will return later on as TA libraries, were created to provide an object enable to properly display the AutoCAD architecture of objects. So these libraries allows you to read, write architectural objects that are compatible with AutoCAD. Typical architectural object is implemented in TIGAR architecture C++ library as a custom object, and which means that it hides all the complexity under the hood and exposes as a form of external APIs the possibility for the programmer to use all these possibilities that are hidden inside this custom object, which allows to reduce the complexity of the program that uses these interfaces. Plus, the ADT libraries use the facet modeler that has been pulled out as a separate module that can be used by members to create their own 3D objects. And we use the facet, for example, we use the facet modeler for our new facet primitives. Now, about our module, or the ADT libraries, how they live in IntelliCAD now. First of all, TA commands module was initially implemented, developed in my microsurvey company, and it was later on donated to IntelliCAD. And IntelliCAD uses TA libraries to draw, manipulate, save, retrieve architectural objects. And this functionality is encapsulated in T commands IREX module and existing forms of just few commands. Currently, we have implemented such commands as wall, door, window, opening, slab, and roof slab. It was said several times before that. Plus, there is the AC object system variable which controls the availability of the TA commands in IntelliCAD. If it's set to off, then no TA commands are available. Any commands run in IntelliCAD will initialize internal dictionaries of TA libraries. We use a dictionary to keep default or the last edited values for architectural objects, I mean default sizes. And if the TA object's default dictionary doesn't exist, then we create it from scratch. And default data consists of 2 data sets. First data set is style data, and stored in AEC standard dictionaries, and the second data set is instance size data. We store it in our own dictionary, and as a part of the initialization, we need to determine proper drawing units and style defaults before we go any further. And usually we are looking for the AEC dictionaries that I was talking about, and if such a dictionary doesn't exist, we use INS units as a default. In more detail, it means that we check to see if this drawing already contains AEC-based data and scale factor. If it does, then we use the existing AEC scale factor. If not, then we consider INS units and set up AEC units to match. Otherwise, it will be quite a mess in our drawing. How it looks like in the code, I could just demonstrate you very briefly. Here we see how we get units and scale factor. See if we already AEC already initialized, and if not, then we get drawing units and adjust our new units according to this variable. And then next step in initialization is create default styles. Currently we have predefined styles for each architectural object, for walls, for doors, for windows. We have a number of styles that we create at initial state. And any abstract architectural object has a should have particular style. Even if it doesn't exist, the standard style is provided for this. This is the style object. This is what brings the abstract architectural objects to reality. I mean, it might be quite complex and sophisticated because it has a lot of parameters that controls the external appearance and functionality of each architectural object. It controls all the properties except physical sizes. And the style object can be assigned to any number of architectural objects, and if we change that style object, all the objects, architectural objects to which it is assigned will change simultaneously. This is just an example of a code that creates a style. I just omitted some insignificant details of code. And first of all, we use the standard API create AC object with this is the code that creates a style for window object, and then we use these values and we tune them to particular values, and then we just set these values to the style object accordingly. Before we proceed to commands itself, just a few words about the benefits of using TA libraries. We get just we get it for granted such nice capabilities as grip editing, copy and paste, automatic wall intersection cleanup. I will show you how it looks like. It makes wall segments to conglutinate to each other as you build the sequence of wall segments, and use the anchor mechanism that knows all the relationship between the parent wall and all the windows and doors that are placed on this wall. And such a nice feature as trim extend, very convenient. Wall command is main construction object without which we cannot imagine any building. We support both linear and arc walls, and as you build a wall, you need just to provide a few parameters like width and height, justification of the wall, which means how it located relative to baseline, and wall style. This is enough to form the wall. Also, we use a position helper to dynamically view the current length of a linear wall segment as it is created. Let me just demonstrate how this command works. So we can run the command using various means. We can use just plain command line like this. Here we can see on the command prompt all the existing capabilities that we can use. Together with that, we see that we can change width, height, justification, and style. And the current values are also displayed in the prompt. Now we can start draw a wall. As you can see, there is a position helper that displays the current length as you move your cursor. You can enter the length using the keyboard. And the segment will be exactly 100 units length. And next segment will start to create. We can enter arc mode the midpoint of this arc, and then continue. Switch back to linear mode, and close the wall sequence. This is not, of course, far from being real. I will just I will demonstrate you how trim and extend works with walls. If we need to cut extra parts of the wall, you can use trim. First cut, we need to select cutting entities, and then select entity to trim. Here we go. Now you can see how this intersection cleanup working. And we can also use extend, which is also a very convenient feature. First off, we need to select the boundary entity and then entity to extend. Here we go. This is how we use trim extend capability. And we can also use the existing contour to form a wall, which can consist of lines, arcs, and polylines, like this. Build a simple polyline. Close it, and then issue wall command and ask wall command to convert. Select all these entities, and now we got a wall. This is how we create the wall. So back to the presentation. This is what about the wall. And now next set of commands is door and window, and they have common parent called opening. In the object hierarchy of ODA library, they have one common parent called opening. It also implemented as a separate command. So we got three commands: opening, door, and window. And they all three have the same set of geometry parameters, like width, height, and header height. Of course, we can create just standalone window and door, but this is not interesting at all, because these objects are useless if not put on a wall. And this mode is much more practical. So as soon as we put this object on the wall, the anchoring mechanism starts working. It knows about this relationship between the parent wall and the windows existing on it, and in such a way we get benefits of it. I will show how. Also, we can leverage the position helper to exactly see positioning the current position as we move the wall before we drop it on the wall. I can show you how. Let's add door. Here we have the toolbar button. We also have a door and a tool palette. We have a great number of all different kinds of doors. And single door, double, and many kinds. Let's choose this one. And now we can edit right away. We can edit width, height, header height, and style at this point. And the system asks us to select the parent door or parent wall on which we place our door. Let it be arched segment of wall. This one. As soon as we move it along arch wall, we can see where to put it. For example, here. A little bit. Let's just edit it a little bit. And as you noticed, when I was moving using grips, this door, I was not worried about should I put it right on the wall. The anchor mechanism, does all this for me. We can add one more object like opening on the opposite side. It's just the hole in the wall. As you can see, the position helper starts working. It works on linear segments of wall, so we can clearly see where to put our object on the wall, and we can enter manually the distance between this part, this point and this. For example, let it be 30. Okay. It is. Now we got opening. We also have can add a few windows. Let's use toolbar button. We may put it here. And another kind of window we may put on the opposite side. Here. Okay. to make you believe that this is a real thing, I just use it to turn a little bit to see that this is the real thing. This is not just 2D picture. And we also have such command and such object like a slab. And I will demonstrate you how to create a slab using snapping, which is very helpful. Let's put a slab that will delimit different levels of the building. We begin to point the vertices of our slab. Let it be this. Then here. Snapping is very helpful here. Let's make it arc. Okay. And close it. So we got the slab as a delimiter for different levels of building. We can view it in more realistic mode. Like this. As you can see, we don't have a lower slab, but upper slab is already there. Well, this is how it works, and this is how nice feature which gives us IntelliCAD environment and infrastructure gives us, together with the power of TA architecture module library, what it gives us the ability. But this is, of course, this is just the beginning. We of course we have missing pieces in TA libraries. We haven't yet implemented such objects like section, elevators, roofs, stairs, railing, column grips. We have implemented a roof slab object, but interface is almost identical to the interface of the slab. The difference is just it just belongs, the roof slab object belongs to a roof, and the slab object belongs to floor, to all kinds of floors. And as far as style management is concerned, we have a hard-coded list of predefined styles that is created on the system startup, and we can choose out of this predefined set of different styles. But it would be much more beneficial to make it possible to extend this set of styles by using style dialog or style manager, which will be able to create new kind of styles for a certain objects. Among the other things in our to-do list is enable such universal, such existing commands, extend such existing commands to act on AEC objects like join, break, stretch, fillet, chamfer, and offset, and to make it work on the walls. And list, for example, list command, have it to provide our geometry properties data for make it work for AEC objects as well. So this is basically all that I got for AEC object for today. And so if you have questions, please ask. Okay. Thank you.